Bill Hurd from Hackaday. Let's do our own surface mount assembly. Okay, I'm going to walk you through everything today that I know about for surface mount assembly. We're going to go through all the steps, including putting the paste down, cooking it in an oven, inspecting it between those steps. Big thing for me. So first, let's talk about the difference. There is through hole. It is what it says. The pins go through there. This is the older technology. It's easier to do at home. A lot of times you can do this with just a soldering iron. Then there's surface mount. Obviously, the stuff's on the surface. Why do that? Less room, right? It's harder to manufacture, but it's less room. Now, that can run into problems, too, where you have the ability to create heat more concentrated, but that's an engineer's problem. We're going to skip that for today. So in the old days, we used auto insertion machines. These things had heads. They'd clamp the pins, squeeze them enough, they drop straight in the holes and release. We call the things for these pick and place because they gently pick it up and place it into solder paste before we activate the solder paste. The pick and place machines usually have visual alignment of the head. I mean, it's very precision work to do this. We can do this at home. I'm going to show you how. Couple simple things. I do like to have, I'm old, right? So I like to have tweezers for my shaky hands. I like to have a microscope for my fading eyes. And I usually use a helper who's young. Okay, so that's how I do it. So let's talk about these things. So let's start with the solder. You're probably familiar with solder in rolls like we have. These come in a couple different flavors, but they tend to be leaded and non-leaded. Non-leaded tends to be silver. There's flux in the core of these. We'll talk more about flux, but it's the chemical that keeps the joint activated correctly during the heat cycle so that it doesn't oxidize. Here's what the paste comes in. That's a hypodermic type needle with a plunger and various needles I can fit to here. But the paste is in there. It is a paste, just like we're saying, with the flux moved in. Now, there's a couple different kinds of fluxes. And I'm not even talking about leaded versus non-leaded for a second. But for both leaded and non-leaded, we have the regular standard rosin flux. We have water-soluble fluxes, which means you can wash them in a washing machine with the right kind of deionized water, and that gets used in production. I use something called no-clean, which tends to be an alcohol-based solvent with some other chemicals thrown in, what I call the magic juju to make that work. So right off the bat, pick a technology. I use the no-clean technology. I use it both in my fluxes these days. The fluxes I use on my bench. The paste I use when I do my own surface mount. Here's a close-up of the syringes that the paste come in. There's 3 different brands here, and you'll need the plunger to go along with it and the needle to go along with it. So let me show you how I store my plungers. Here's one of my containers that I keep an assortment of things to help me with my solder paste. I have a selection of needle sizes, and these are sorted by size written on the inside of the container here. I also have different fluxes, lots of different fluxes, different ways of scooping and slobbering solder paste around. And then I also keep in here the little smaller picker-uppers. You can see the little suction, real tiny suction head. Here's a bigger suction head. So I keep those in this container. In this container, I keep a selection of the syringes themselves, the caps that go on the ends. This is actually a hose. This plugs into the back of a syringe and applies pressure. This is for a solder dispenser that I'll talk about more, but I don't use. I prefer solder paste masks. You're going to hear me say solder masks, paste masks. So real quick, a thing about solder paste storage is this solder paste is volatile. The fluxes leave it quickly. If you can't store this for a week, you really can't. I use a refrigerator to store mine, but I use a paste called Zephyr paste, which the guy, David Z, formulated this to have a better shelf life. No, I don't work for him, but I use this product. Otherwise, if you get your solder paste from places, SR Solder, I get it from various places, If you can't remember when you bought your solder, throw it away. It's too old. If you bought it last week, it might be too old. If it's got a scum on the top, it's too old. The consistency of the solder paste in production is paramount. They warm it to the right temperature. They make sure it's the right date. They keep it sealed. I keep it sealed in the syringes, and there's actually a hanger for this in my little refrigerator. These cheap little things. Don't put this in your break room refrigerator. There's lead in it. There's other chemicals. So you store it like this so that there's not a chance for a skin to form. So the plunger is in here, and we pull the paste out of the bottom. And so this is the worst part about the paste. You almost got to buy it before you use it or get a longer lasting paste, and then store it in a refrigerated environment, preferably non-condensing. These things condense like heck. I have to open it and wipe the water out of it every now and then. Here I threw some of the solder paste under my microscope here, and you can see the tiny little granules of the metal, and they're being held in place by flux, and you can see the surface tension here as this is drying out, and believe me, it's drying out even as it sits here. So this is what it looks like beforehand. If you have a bad solder, what you'll find is these granules clump together and they become more grapey looking. No, they're not grape size, but they look grapey when you look at them under magnification. So, but this is pre-soldered solder. So let's talk about surface mount technologies for a second, because what I'm showing here is a very small one. That's not the right one. I'm showing a very small one on 50 centers. And the reason this is so small is I'm trying to insert a board between literally this board, which is complex of itself. Between here and here, I'm sticking a whole level of level translators, actually. I like to be able to convert from 3 volts to 1.8 to 5 volts. And so I built this little board that fits right in between those two things to do that. So I cannot hand solder something that small, but let's talk about hand soldering. You can hand solder this. I've done many, some SMT, 0.1 inch centers, SOT devices, SOIC. I'm not going to show you here, but you can hand solder those. On the topic of hand soldering, or even soldering like we're going to show here today, let's talk about sizes. When I say 50 centers, those are those little tiny dinky things. 0.1 is the one you're used to seeing in dips. There's a sizing out there, 0603, 0805, 1206. Those represent the families of sizes generally. Just think of it that way. I don't go smaller than 0603 for what I do here in the bench. I can go 0402, I just don't need the aggravation. And 0805, it's a little too big for me. I might do LEDs in that size. Then the ceramic, electrolytic caps, those have their own sizing things, A, B, C, D, other footprint oddities. So I tend to do 0603, and with that I can almost hand solder them, but again, I use a technique for laying the paste down in an orderly fashion. Here's a ruler from Adafruit actually that shows some of the different SMT sizes. A lot of people make these rulers. This one happens to be Adafruit's. And I'm going to show you a close-up. I wanted you to see the size of the ruler so that you get a sense of scale here. So here's the 0.5 inch, 0.05, that I'm talking about being able to do. There's even smaller 0.04. I could probably do them. I haven't done them using my own techniques before. And then you get to sizes like this, and they're just positively doable using the techniques here I'm showing today. Here's different sizes of SMT parts. And so you can see the 0603 is down around this size here that I used. You can see with my tweezers, that's very grabbable. Here's the different size capacitors I was talking about. Whoops, is that them? There's A, B, C. These are oddball shapes. But when I say 0603, I'm talking about devices typically this size. You see the next step down is I'm sorry, right there is 0603. Next step down is getting pretty hard to grab. And then you get to 0201, you actually have to watch that you don't accidentally inhale them. Now, one way to do solder paste would be to actually leave a trail of paste using a syringe down the line where it's thin enough that when the solder melts, it pulls away and just coalesces around the pins due to surface tension. Another way is a solder dispenser. I do not use this. I try to use this. I don't like it. has a foot switch, it has an air source. You step on the foot switch, and it puts pressure on your syringe. What it is the pipe. You get some tubing. Tubing leads to the back of the syringe. This thing runs when you step on the foot switch, and it forces paste out of the syringe. The problem I have is when you go to put that on the board right where you want it, it doesn't always wet and stick to the board. Sometimes it comes up on the needle, and now I've got a double load for the next pad. Cleaning the board is essential to all of this anyways, and my board was clean when I used to try that, but I've skipped that step that said before we put solder paste down, we clean it. I use 100% alcohol. I use some other critters too around here. But again, I couldn't get this to stick. Let me show you what I do use. This is a stencil. You can get these at the same time. Ooh, 3D House of Stencil. Ooh. You can get these made at the same time as you get your PC boards fabbed. It's from the same files. They do add a paste file. You can figure these out without them. You can figure them out from just an Eagle board, for example. But this is a solder mask without a frame, and you can actually lay this on top of a board, right? And you squeegee solder paste through it, all right? You take something like this. Hey, here's a Nosh Stencil solder paste spreader, credit card size thing. And what you do is you'll squeegee the paste through so that wherever these holes align, the paste will go through and land up on your board. I don't use these. My hands shake too much. I usually tend to work in ways that I'm used to from production. I don't use them without frames. Let me show you what I mean by a solder paste screen with a frame and a frame holder. So I've decided to show you the actual stencil paste process here. Here's the frame being held in the stencil frame, and the PC board is underneath here. And the idea here is that we're probably going to do off camera is we use PC boards to shove it into place, or we can either unscrew the clamps that hold this and move the stencil into place. Here is a stencil, tight as a drum. They stretch these. This is a stencil in a frame. These come in somewhat standard sizes, and they fit my stencil holder I'm going to show you in a second. But basically, it's the little core here is the holes in it, and you can get this panelized. So let's say instead of doing one of these where you do the solder paste per board, you can do it to the whole board, to a whole panel, and do 20 or 30 boards at once. But for here in my lab, I just generally shoot one right in the center. This is a frame, Osh Stencil sells frame, Osh frame, something like that. I get my framed stencils, again, from the same place I get my PC boards from overseas. Actually just costs a little more to ship them than the boards, but these are inexpensive as well. Here is a stencil machine. You can see it's counter-levered. And what we do, put that down, is we put the board we want to solder paste under here, and then we'll squeegee, remember, credit card, we'll put a line of solder paste here and then squeegee it across those holes, and it's like silk screening. It'll put the paste into the pattern on the PC board. Now, I use something a little better. This actually came with my solder frame. This looks like just a piece of hard plastic, kind of two pieces. This actually bends a little bit. And when I squeegee using this, it gives just enough that the solder paste gets pushed through the holes without smearing and getting under it. If you press down real hard while you're doing this, it'll push too much paste through, and then when you lift this up, the board will stick to the bottom. If the board sticks to the bottom of your frame, of your stencil, wipe it off, do it again. Let me be real clear. Cleanliness, I said wipe it off. I start by wiping this thing down. I actually have stencil cleaner, which is like you don't want to drink that stuff. And then I'll clean the board, and then before things get dirty again, I'll go ahead and squeegee my solder paste across. So again, this takes a certain feel to it as we do it. Now, one of the things you can do to line up your boards is use other boards on the sides so that when it's leveled, the boards act as a holder with the board you want in the middle. So you can do that for whether you use the frame or non-frame. A lot of people will build a little barrier of boards around it, put the board they're doing in the center. That way everything's level. Okay, very first thing I did then after we did this is I cleaned my solder paste screen. All those tiny holes you let solder paste form in there and dry, it's a mess to clean up. This is now going under the microscope to check my registration, and I'm going looking for solder bridges. If there's already a solder bridge here, you're going to have a solder bridge in the final product. So it's the way surface tension works. It can be misregistered a bit. That's fine, but again, I'm looking for even a hair or something that's got solder paste following it across the shorts, across the different pads here. Okay, so placing parts onto this board is critical. If you look at those little guys, they're small, right? Well, how do you pick them up? How do you pick them up and place them? Well, tweezers. Tweezers first one. Tweezers work for small parts. By the way, if you drop a part, throw it away. That's what I do. Because I no longer know what the part is. When I keep my parts on reels. Or cut tape. Cut tape is simply where you'll cut part of this off, and this will be what you buy from, the parts are in here. And they're contained by this tape on top, and this feeds through a machine. Well, that's good for me too. I can store a bunch of these in my reel holder up here, or when I buy the parts, I buy them on cut tape. I don't open them ahead of time or anything. I'm taking them right out of the tape and putting them on the board. That's the only way I know the value of them. I saw Seed Studio had one of those LCR tweezers where you can put it on a part and it'll tell you the capacitance, resistance, inductance, and help you identify the part. That's kind of cool. I wish I had a pair of those around here. I might try them. So, but here's a way to put the parts down. First off, the manual way. See, that's a little sucker. That actually, if I were to attach that to a part, you can lift the part and put it down. That's a big sucker head, but they make small ones, and it's operated right here. There's an automatic version. This is actually a suction pin. Oh, this one's made to be a suction pin. You hook suction to these that are made for this, and you use the suction of the device goes all the way to the little suction head, and you can pick the part up, and you usually cover with a hole in your finger. You'll lift it to drop the part, you'll place it to pick up the part. This didn't work so well for me. I have two of these. I tend to be a tweezers kind of guy, or a manual solder sucker. Now, tweezers, let's talk about them. If you get big flat packages, it's imperative that package be flat on the PC board. If you drop it pinned down first, that pin will bend up and you end up with a bad corner of the chip. So that's the problem with tweezers. If you're picking them up and one end goes low while you're putting it down, you can bend the leads. So you got to pick that part up flat and you've got to lay it down flat. So now some people use these. There's some Hackaday articles on how to convert these. Like I said, I actually got pretty good results from an aquarium pump. All right, it's hammer time. Time to put this in the oven. Again, this is a converted Black & Decker oven with DEI insulation all over it, an additional heater, and a Control Leo 3 module that runs it. This module learns this oven. And I've got different configurations, whether I have a split plate or not in here. And mainly what I'll do is I'll recalibrate. It takes an hour to calibrate this oven. Hey, it means it's good, right? If I'm doing single runs, I'm calibrated right now for very small quantities. If I wanted to load this up with 10 PC boards, I would probably stop and calibrate it for 10 PC boards. I'd actually throw them in there, not with paste, but just to represent the thermal mass. So we insert our board into here. The profile is chosen for lead in this case, and I'm going to run the profile. So we actually get a little profile here on the screen, and I'll show you in the article in the post what the different phases of that profile are. All right, here's the view through my the stereo microscope I showed you, and we're looking pretty good. If you look at that row of pads there on the right, I'm not seeing any solder bridges. I can see more than the camera shows. It looks pretty clean. But I'll inspect this whole thing, make sure there's no solder bridges. If there are solder bridges, I will attempt to remove them with manual desoldering process, which I have a video out here at Hackaday about all the different ways you can desolder SMT. So hopefully I'll try and remember to link it in on the post. All right, my last step is, especially if I'm making the board for somebody else, I clean the board. I have an ultrasonic cleaner. I have two. The other one's over there somewhere. And this will heat the fluid that's in it and ultrasonically clean it. Do you need to? Usually not, unless you're doing something really high frequency or real low leakage. And it's usually not the flux that's the problem. It's what gets attracted to the flux. We used to have a problem with greasy, fuzzy stuff getting into our flux in the old days on analog circuits. I do tend to clean it. I use number 35. I forget, I researched this real heavily, what I could get for here in sizes. I don't need 55-gallon drums. So I get mine from SRA. If you Google that, you'll find they make soldering supplies. So after the board gets soldered, I'll do an inspection and clean it, or I do a cleaning and then inspect it. 050 centers, real micro small stuff, and it worked just fine. So you can do your own surface mount assembly at home. It starts with cleanliness, a good solder paste, a good fresh solder paste. You also mix it up real good. You don't let the skin get into it. Like I said, if you got a skin on it, it's probably no good anyways. You stick it through a mask of sort. You either put it down with a solder dispenser or be your own solder dispenser with a syringe. My son's real good at that. Or you use a solder mask, paste mask, and you squeegee across it, and that puts the solder right onto the board. We then get it in, we then inspect it, make sure if there's a little sloppy solder trail, wipe it off, start again, and that usually, you'll see it. You'll see the issues that would have been problems if you inspect it between those two steps. Then we get it into the oven. I don't know if I said that, and then in the cleaning. So hopefully this showed all the steps you would need to do this yourself. Again, I use 0603 size components just fine. I make sure my components are on cut tape. I like to have reels of the common components. And boy, we can turn out our own boards that we could only have dreamed of in the old days. You can do from home with just a few pieces of equipment. So Bill Hurd from Hackaday. Hopefully this helped you get over the fear of doing your own surface mount assembly, if nothing else. You know, I know I went too fast to actually see it, but know those steps. Know that inspection helps. Know that your paste is all important. And right behind that is a good, decent oven. And again, this is just, not this one, but the oven I showed is just a convection toaster oven, Black & Decker, $25, that's been converted with a kit for Control Leo 3. So Bill Hurd from Hackaday, let's talk about something next time that's different than what we just talked about today.